And the last thing I want to do is I want to take a velocity time graph and convert that into a position time graph, or excuse me, a motion map. Um, I think what I'm going to do first is I'm going to take a look at my motion map, or my velocity time graph, and I'm going to convert that into words. I'm going to identify my motions here, and then I'm going to convert that to a position time graph, and then from there go to my motion map. So essentially I've worked up to being able to uh, describe motion in all four ways: words, velocity time, position time, and a motion map. So let's take a look here. This first motion here, the velocity time graph is in the negative region, so this would be towards, and it's a horizontal line, so that's steady, although that's all we've dealt with thus far. Next unit we'll deal with non-steady motion. And then since I do have something to compare this with, this compared to this would be slow because of that distance or height away from zero. So we're going to call this slow. This motion here, very identifiable. Velocity of 0 means that it's not moving, so this must be standing still. And then my last motion here, it's in the positive region, so it's moving away. Horizontal means it's steady. And again, we said that this compared to this is fast. So we've got away, steady, and fast. What I'm going to do is I'm going to stack my position time graph right below this. So I'm going to go ahead, I'm going to create a position time graph for this motion right below here. I'm going to position, time, here's my 0. Let me go ahead and put in a little mark here to separate my motions. I know I've got 3 motions here, and so these things, this is where the motion's going to change. All right, so I've got my 3 motions. I've got towards, steady, slow. I know what that looks like. Towards, steady, slow. I can't be possibly starting at 0 and heading towards, because that would bring me down here. That's not going to work. So I'm just going to pick a spot away from the origin, and I'm going to start moving towards at a slow pace. And then stand still. And then I'm going to move away, steady, fast. So this is going to move away, so it's going to be a positive slope, and it's going to be steeper than that original slope. So there we go. Away, steady, fast. Now I'm ready to go ahead and turn that into a motion map. Let's go ahead and get our motion map set up here. Again, it's nothing more than a number line, position, 0. And there we go. We've got our motion map. Again, before I get this started, what I'm going to do is I'm going to go down here and talk a little bit about the spacing, make some notes. I know this is not at 0, so not at the start. So at time 0, I'm not going to be at this spot here. This is going to be evenly spaced, and compared to this, these will be close, so even, but close. The dots here are going to be stacked. Just making some notes for myself here. And then these are going to be even, but wide. So let me go ahead and get started here. I know I'm going to start my motion map not at 0. So I'm just going to pick a spot out here. Here's my time 0, and I'm going to label that right away before I forget. So I'm going to have dots everywhere. So that's time 0. And I'm going to start moving towards. So it's towards, steady, slow. So go one dot at a time here. I can tell that I'm moving towards steady. I can change at any given time here now that I know that I'm going steady towards. I'll start stacking them at this point. Here's my standing still. Giving myself some space here. Again, at this point I can tell that I'm standing still. I can go ahead and start moving away, steady, fast. Since these were 1, faster would be 2, so I'm going to go ahead and put this out here. Put this out here. I'll put this out here. At this point I can tell that my object is moving away. Again, these need to be even. They are. And they need to be wider than this. They are. So at this point I can go ahead and I can stop this. I can tell that I'm moving away steady fast, and I can fill in my velocity vectors. To get from this position to this position, I need to be moving. I need some sort of velocity to get there, so I'm going to put an arrow there. These guys are evenly spaced. I've got a constant velocity, so these are going to be all the same size. Makes life easy. To get from this position to this position, I'm in the same position, so there can't be any velocity. I'm not going to put an arrow on this. I'm not going to put an arrow on this. I'm not going to put an arrow on this because, again, I'm in the same position. There is no velocity. Velocity is 0. I'm standing still. To get from this position to this position, I definitely need a velocity vector, and it's going to be larger than this one, and it makes sense. I got more space to draw it in. So I'm going to just go ahead and draw these all the same size. And again, I've got this last one. I'm going to assume that the motion continues on as it has been for the last couple of time frames. So again, I'm just going to go ahead and put a velocity vector on that, same size as the others, and I'm done. So again, what I did was I convert my velocity time to words. And then words to position time, and then position time, to my motion map. You can jump right to the motion map. I'm not going to say you can't, but sometimes it's easier to go with the in-betweens, especially when we're first starting out. Gives us a lot of practice with the other forms of representing motion. I highly recommend this, at least at the start. If the question simply asks for a motion map of a certain velocity time graph, I would say it's really difficult to go right from the velocity time graph to the motion map. I would at least put down the words. I'm not saying it's impossible, but the words make it easier to picture, to get your motion map, your final motion map.